Very pleasant good afternoon. I would like to present the video recording for the classification concept in data mining. So, from this fundamental concept, I would like to use that what is classification, what is prediction, how to construct the model for you by using the classification, what kind of algorithm is most familiar use for all kind of application. That concept I'm going to discuss in this video. So first thing, what is classifications and prediction? What are the differences? The classification and predictions are the two forms of data analysis. That's it. You analyze the data that can be used to extract the model. That should be describing important data classes or to predict the future data trend when you're going to use prediction. Classification predict only the categorical, that is discrete or unordered class labels. That's it. Prediction model is a continued valid function which is going to predict the future trend by using the in terms of numerical data. So classification predict the class label, it is string format or discrete nominal data. But they classify the data, how it is classified the data based upon the training data set, since the training data set consists of all the attributes along with the class labels. The class label in classifying the attribute and use it for the classifying the new data. For in case of numerical prediction, model continue valued functions, that is predict the unknown or missing values. So this classification predictions we can apply for any kind of application. For example, loan approval or credit approval, medical diagnosis, fraud detection, web page categorizations. For in case of loan approval, it is mostly used for the borrower. After analyzing the borrower data, the bank official considered whether he is eligible to give loan, is it safe or risk, that can be determined by using the classification. Medical diagnosis. The medical diagnosis it depends upon the patient, the tumor of the patients. We can give in what kind of treatment we need to give for the particular patient, either treatment A or B or C. According to that state of the tumor, we can determine the medical treatment. Fraud detections also we can determine by using the classification, the page categorization. So that is web page, especially for web log file, we can use the web page categorization. We can categorize the web page either maybe content or maybe structure or maybe web usage mining. Accordingly, what kind of data the user is trace out for the particular website, that can be determined by using web page classification, web page categorization. And then it is actually classification consists of only two-step process. The step one is called as a model construction, and step two is called as a model usage. Model construction is nothing. That is, we are going to give an input as a training data set. The training data set is a belonging that belongs to predefined class. So data set consists of set of tuples that each tuples are represented by set of attributes. Maybe they are as A1, A2, A2, AN, or maybe X1, X2, X3. So it is containing the class label also. And then set of tuples is used to that is model the construct the model. So the model is represented as a maybe, and the model is represented as a classification rules or maybe decision tree or maybe mathematical formula. So that is the way we are going to build the model. Y is equal to f of x in the sense x is called as one of the set of tuples that consists of set of attributes, and f of x denote as we are going to apply either decision tree algorithm or some mathematical formula. That is, they apply some mathematical formula in order to predict the y. Y is representing as the outcome or class label of a particular tuple. Model usage in the sense they are determined the accuracy of the model. So no label of the sample is compared with the classified results from that model. That is most important. Known label of the test sample is compared with the classifying results of the model from the model. Next one, accuracy rate is a percentage of the test set sample that are correctly classified by the model. But here we are giving only the test set as an input to the input that can be used to determine the accuracy of the model already built in. So model usage in the sense this when the test is independent of the training data set, in order to determine the accuracy of the model. If the accuracy is acceptable, then the model can be used in a real life examples, right? And next we can go for this is for the construction of the model. So how we construct that, we have constructed the model using the training data set. So here the name, rank, year, or three attributes, and tenure is called as a class labels. Using those training data set, we are going to pass to the classification algorithm. Classification algorithm may be decision tree, or maybe a row-based classification, or Bayesian classification, or back propagation algorithm. So, in order to build the classifier model, then we are going to determine, then it is going to produce the results. So, if rank equal to professor or year equal to greater than 6, then we are going to then determine the class label tenure equal to yes. So, this is the way we are going to construct the models. After constructing the model, we are going to determine, that is, use the model in predictions. So, we are that after that model is constructed by using the classifier, that is called as a classifier. So, classifier, we are going to passing the unseen data, that is test data, that does not containing any class label. That is the most important. We are going to pass the unseen data, that is the your name and then rank, and then we are going to pass in here. Then we can determine the class label whether the tenure is yes or no. Here we are passing that unseen say data, professor, and then 4 years experience. 4 years in that scenario, the tenure equal to yes. So according to that test data, we can pass the unseen data. We are going to predict the result. We are going to compare the results accordingly. We can determine the accuracy. If the accuracy is acceptable, then this model is come to the real usage, right? And then the most important algorithm for the classification is called as the decision tree algorithm. So the decision tree, why it is considered as most important? Because most of the people, they are easy to use, easy to understand. So because it consists of the domain, no need of that is a huge amount of knowledge, but little bit of domain knowledge is enough to understand this concept, and then we can apply any kind of any amount of large volume of or abundant volume of data we are going to upload for in the decision tree algorithm. We can predict the class labels. So the decision tree induction is a learning process. Decision tree from the classification class label training tuples. The decision tree is a flow chart like a tree structure where each internal node, that is non-leaf node, that denoted a test on an attribute. Each branch represents outcome of the test. Each leaf node is representing as a terminal node, that is class label. So the three things we need to know that. So the root and intermediate node are the attribute testing, that is denoted as a rectangular shape, and the leaf node is representing as a, that is class label, that holds a class label, and all other branches are representing as the outcome of the each attribute test, right? And next we can go for decision tree, that is here the each part from the root to leaf representing as a conjunction of the attribute test. That's it. And a tree itself is a disjunctions of the these conjunction. So here will be considered age is one of the attribute, student is another attribute, credit rate is another attribute. Then we can determine whether he is able to buy computer or not. That is buy computer or not. That is known as a class labels. So that is a tree structure we will be considered for this example, right? So this is an algorithm we have to use for this decision tree. So first thing we can go for this. We have considered decision tree algorithm. First thing we are going to generate the decision tree. One, for example, create a decision tree. We are passing two in parameters. One is called as a data set, another one is called as the attribute list. So first thing we are going to create a node, first node. Okay, so node n, that is called as a root node. If they represent, you know that all the we are passing the these data set containing only training data set, and second one we have considered the attribute list. What are the attributes are available for this train data set except the class label, right? Including class label also, sorry. So create node if tuples in D, or assume that the T consists of 25 tuples. The tuples in D all are the same class as C. Same class is assumed like that. Yes or no? That's it. So here we be considered as a yes. Then return node as a leaf node that should be labeled with the class C. So no need to go for further tests because all the tuples in T belong to same class S in the sense why we can go for the next level, that's not necessary. The return node N is a leaf node that labeled with the class C, that is S in a S, or maybe no, in this is no. Suppose if there another condition, this is for two things instead of stopping conditions. So if all node belong to same class, we can stop it. No need to go for further process. If attribute list is also empty, then we can also determine the result. That is return n as a leaf node that labeled with majority class D. That's most important. So assume that if attribute all the attribute we have tested age and then what is that age we have tested, and then student is also tested, and then credit is also tested. After testing that, no more attributes for further testing, attribute list is empty. Now we have considered majority. If for a after 25 tuples in the D, so 16 tuples are belonging to S, and the remaining tuples are showing that 9 tuples are no in the sense. In such a scenario, we can take a decision that is class label C as yes. The majority is S, then we can class label leaf node should be labeled as a S in the sense. Okay, and then that is the first two if statement is called as we are testing the same class, and with the attribute is empty, we need to stop the process. So first thing, otherwise, else, otherwise we can go for attribute selection method. So several attribute selection method is there. That is one as called as a attribute selection method. We have information gain, uh, gain ratio, gain index. So several methods there for selecting the best attribute methods. So using that, applying that attribute selection method, we are going to pass the data set as well as attribute list, that is age, and then followed by students, and then followed by credit rate. We are going to apply all those attributes. For what? We are going to find the best splitting criteria, which attributes most important according to the information gain or maybe a gain ratio. We can determine which attribute has the highest ratio that could be used for selecting as a best splitting criteria. That's it. Okay. So now the node label node n with splitting criteria. So, okay. If the splitting attribute is a discrete value, take as example. I'm taking some discrete in the sense string type, not a numerical data. Then we can go for multi-way split allowed here. So for example, here we consider splitting attribute may be age in the sense we have considered the age as one of the attribute that is considered best splitting attribute. It consists of value maybe youth or middle age or senior like that, right? So in that scenario, it does consist of more than that is multi-way splitting, right? So that is most important. That is most important. That is most important. So and then the attribute list is the attribute list. Then once the attribute list is considered, then we can go forward. We remove that splitting attribute from the existing attribute list, right? For now, after splitting that D data, then for each out, what is the outcome of the D? That D consists of D1, D2, D3, because the data set may be consist of that is age, maybe youth, and then middle age and senior. Youth may be consist of 10 record, and then middle age may be consist of 10 record, and then senior may be consist of 5 record. You are going to apply all those partitions, that generalization of algorithm that is going to be applied for all the partition. Now let Tj is the set of tuples in T satisfy the outcome J, that is in case of youth in the sense. Then after that, if Tj is empty, then we are going to attach the label or leaf label with the majority of our class in D node n. So in such a scenario, we can consider this. So no more further TJ is there, tuples is there. Then we are going to majority of the vote that a class label should be consist of majority. So else we are going to attach the node returned by the attach the node returned by the generate recursive the decision tree. So we can go for that recursively call that decision tree algorithm. If Tj is empty, in the sense we are going to determine the majority classes, or else we can go for further process whether it is all the age equal to youth in the sense all the classes same classes. If so, in the sense we terminate the first point. Attribute is empty, we are going to, if so, in the sense we are going to determine the majority. Otherwise, we are going to find the next splitting attributes. So okay, that process will be repeated for age as well as student as well as credit rate. So because major 3 partition the data into D1, D2, D3. So J vary from 1, 2, 3. Accordingly, you can determine whether he or she able to buy computers or not. That is the major important algorithm. It's easy to understand, and then only the few date know that is domain, little bit of domain knowledge is enough to understand those concepts. For this, I conclude this classifications. Thank you. Thank you.